Okay, in this video, we are learning about factoring quadratics that have a coefficient of something other than 1 on your x squared. And the way we do this, the first step really should be to see if there is a GCF between all three terms here. In this case, there are none, so we can proceed from there. And then what we would do is we start listing, well, we know we're going to have two binomials here. So we know we're going to have those two sets of parentheses like that. We know there's going to be an x here and an x here, but we don't know what the coefficients of those x's are. To work that out, we need to look at the factors of both the a, the term in front of the x squared, the coefficient of the x squared, and the c, the constant at the end. So the factors of 5 are 1 and 5. Those are the only two. That's a prime number, so those are the only factors. Factors of 8, you could do 1 times 8, you could do 2 times 4, and those are the only factors there. Now, since this is a positive 8, but the middle here happens to be a negative, chances are we're dealing with some negative numbers in here. So I could have -1 and -8, -2 and -4. Those would add up to give me a negative, even if these were all positive, 1, 5, 1, 5, 1, 5. And it's usually safe to assume, to work with, 80% of the time, it's safe to assume that we're working with positive coefficients for the a. So we don't really look at the negative factors there unless we absolutely have to. All right, now the way we do this is we're going to look at this first row here. This first row says that the coefficient on this first x is going to be the 1. This is a coefficient of x as well, so that's going to be this one over here. This becomes the constant in this binomial. This becomes a constant in this binomial. So if I were to write the answer using these numbers, assuming that that was the answer, I would have x plus 1 and 5x plus 8. To see if that actually is the answer, I would use the distributive property to multiply. The first gives me 5x squared. Oops. The outer is going to give me 8x. The inner is going to give me 5x. And the last is going to give me a positive 8. Now, if I've done this correctly, and when I've listed these things here, I shouldn't even have to really worry. This and this should definitely work out to be 5x squared and 8. Because this is always going to be the product of these two. This is always going to be the product of these. This is always going to be the product of these two. So when it comes to checking to see whether these are the factors or not, it's looking at that outer and inner to see whether they add up to the right number. Now, do 8x and 5x add up to 14, negative 14? No. 8x and 5x add up to negative 14?
Oh, 13.
That's going to be a positive 13.
Yeah.
Not, so I can cross off that combination. That's not going to work. It's definitely going to be something with negatives. So let's skip that second one. Let's go to the third one. Let's say we have x plus, well, not plus, so x minus 1 and 5x minus 8. All right, now doing just the outer and inner, outer is giving me a negative 8, inner is giving me a negative 5. So that's going to be a negative 8x and a negative 5x, which does not equal negative 14x, does it? No. All right, so I can cross off that one. The next one would be x minus 2 and 5x minus 4. Doing the outer, I would get negative 4. Inner, I get negative 10. And negative 4x minus 10x does indeed equal negative 14x.
What, a negative minus a negative?
Negative, I'm not subtracting a negative, it's a negative minus the positive 10x.
Oh, okay.
If you think of that as, you could also think of it as a plus the negative 10x like that. Okay? So this is the correct factorization for this one. Now, if that one hadn't worked, I might have had to continue by working with 5, 1, negative 1, and negative 8, 5, 1, negative 2, and negative 4, because the order here does matter. If I do 5 times negative 8, I'm going to get negative 40, and 1 times negative 1 is going to give me a negative 1. So I'd have a negative 41 when I sum those up. This would be a negative 20 and a negative 2, which would be a negative 22. So it's very important that when you're doing this method that you actually do write down the ones, at least the ones you use. Because if you don't write down the ones you use, you're going to forget what you did somewhere along the line. You're going to keep going through options and options. You're going to go through all these things. And trust me, from experience, you could spend hours on one problem if you don't take the time to write it down to make sure you are not redoing ones you've already done before. Yes, this does basically boil down to a guess and check. It's an educated guess and check, but it is still a guess and check. Okay, now we're going to walk through that same problem, only this time we're going to use what is known as the AC method. It's called the AC method because the first thing you're going to do is you're going to multiply your A term times your C term. Because the quadratic form is ax squared plus bx plus c. So the coefficient of the x squared is known as a, the constant is known as a c. When you multiply the two, it's like saying AC, which is why we call this the AC method. It is also known as the illegal move method, which we will talk about as I go along here. All right, the first step, as I said, is to multiply. Well, the first step should always be factor out of GCF, but we already know there isn't one. So we're going to do the A times the C, which is we're going to drop the A, and it's just become x squared minus 14x plus 40. Now, it looks like one of those simpler quadratics where all we have to do is figure out what multiplies to give me this, but adds to give me this. And looking at it there, we know we're talking about two negatives. So we're going to have an x and a minus, an x and a minus. Because the only way two numbers could multiply to give you a positive, but add to give you a negative, is if they're both negative. Now, the factors of 40, to get negative 14, it should be pretty obvious that you're going to be looking at a negative 4 and a negative 10. 4 times 10 is 40, and negative 4 plus negative 10 is going to give you a negative 14. But that won't factor back, that won't multiply back to give you this now, will it? No. So what we have to do, we remove the 5 here. We have to bring that 5 back. Now, the 5 was what was known as why we refer to this as illegal move. Doing this 5 times the 8 seems like it's a completely illegal move. So now we're going to undo that illegal move by bringing the 5 back in. So this is going to become 5x minus 4 and 5x minus 10. I brought that a back into both places because it was on the x, and now the x squared is in 2 places, so we're putting it back in 2 places. But since I only took out one 5, it seems odd that I should be putting back in 2 5s. Well, you'll notice now that this binomial over here has a GCF of 5. So if I take out that GCF of the 5 from here, I end up with x minus 2. Now, normally you would put the GCF out here. But as I said before here, we took out one 5 and we put back 2. So this 5, we're going to get rid of. It's going to disappear. So our final answer is going to be this 5x minus 4 and x minus 2. And we should always, anytime you do the AC method, you definitely should double check your answer by doing the distributive property or FOIL there to multiply it out. 5x times x is 5x squared. Outer, 5x times negative 2 is going to be a negative 10x. Inner, I get a negative 4x. And last, I get a positive 8. That would combine the like terms here, and I would get a negative 14x for my b term there. So it does double check as factoring back to that. So this is my final answer, which does match the way we got the answer we got from the other one without having to list all those different factors off to the side. All right. For this one, we're using the textbook method. But first we should notice that we have even number, even number, even number. So is there a GCF? There's a GCF of 2. So I'm going to factor out the 2, and this becomes 6x squared plus 31x plus 35. Now I can temporarily ignore that 2 for now. It's going to be part of the final answer, but as far as factoring this quadratic is concerned, I'm focusing in on the C and the A value here. The factors of 6 are 1 and 6, 2 and 3. The factors of 35 are 1 and 35 and 5 and 7. Now, chances are we're probably not going to be, let's not guarantee. Let's take a look at the first option there. 1 and 6. I could have 1 and 35, or I could have 6 and 1 and 35. Or I could have 2, 3, 5, 7, 2, 3, 1, 35. I could have 2, 3, 7, 5. And I could have 2, 3, 35, and 1. I could have 1, 6, 5, and 7, 1, 6, 7, and 5. So this is like all those different combinations of those factors. One of those has got to work. Now, since we have a positive and a positive, we can be pretty certain that this is all going to be positive, so I don't have to worry about negative factors in this. Looking at this first example here, this first row here, this would say that I have 1x plus 1. That's taking this as a coefficient here, and this is the constant, times 6x plus 35. Now again, I could ignore the first and the last because I know that they're going to work out correctly. But looking at the outer here, I would get 35x, and the inner would give me a 6x. Does that add up to 31x? Does that add up to 31x? No, it adds up to 41x. So that's not going to work. Now, I'm pretty sure any combination that's going to have 6 times the 35, that's not going to work. So let's take a look at this combination. If I do 2 times 7, I get what?
14.
And 3 times 5 is 15. So 14 and 15 would add up to 29. Pretty close, but not exact. Let's see. 2 times 35 is 70, plus 3 is 73. That's not going to work. 2 times 5 is 10. 3 times 7 is 21. Does that add up to 31?
Yes.
Yeah. So there's our answer. We just need to write it out as 2x squared plus 7 and 3x, sorry, not square, this is not a square here, this is just x, and 3x plus 5, and don't forget that GCF of 2 is there. This is our final answer, and we could FOIL it out to make sure it works. Now, we've run out of time for the... Okay, let's do this same question using the AC method. We would still have to factor out the greatest common factor of a 2, because you still want to be working without that GCF in there. So 31x plus 35. Okay, then you would do the A times the C, which is going to give you, I'm going to temporarily ignore this 2 for now. I'll bring it back later. I'm going to have the x squared plus 31x, and it's going to be 6 times 35, which is 180 plus 30, that'd be 210. Okay, now we need to look for the factors of 210 that are going to add up to give me 31. Well, again, I kind of get lucky here because I can see that, well, one of the factor, if I use a factor of 10, 21 times 10 is 210. It also adds up to 31. So here I can see I'm going to get an x plus 21 and an x plus 10. Now I need to undo the illegal move here by bringing the 6 back in. So it's going to become 6x plus 21 and 6x plus 10. Okay, now in that first binomial there is a common factor of 3. We factor that out, we get 2x plus 7, and there's a common factor of 2 in the second one, which is going to give us 3x plus 5. Now, in the last one, we did remove that extra 5 there. We got an extra 6 in here now. Well, notice that 2 times 3 is going to give you 6. So we're going to drop those 2 as the GCF, because we put in 2 6s. We only wanted 1, so we take out that. Notice you will be left with 2x plus 7 and a 3x plus 5. Put that GCF of the original GCF of 2 out front there, and this is the factorization, the same answer we had before. If you do 2x times 3x, you're going to get 6x squared. 2x times 5 is 5x. 3 times 7 is 21. So that, 10x. 10x and 21 is going to give you that 31x, and 7 times 5 gives you the 35. Multiply all that by 2, and you'll end up with the original quadratic there. So as you can see, that AC method kind of prevents you from needing all those extra factors out here. Not always. Sometimes this number here can be quite hard to find the factors for. There could be a lot of factors for it. It could be very difficult to work it out to find the ones that add up to the middle. But sometimes this AC method can be quicker. Okay, we're going to factor this one using the textbook method. Now, is there a GCF through the whole thing? No, because the factors are 14, 33, and 18. There's going to be no common factor. There are common factors between individual pieces, but 3 is a factor of these two, but not of 14. 2 is a factor of these two, but not the 33. Basically, there's no GCF. All right, so for that one, we need to start listing the factors of 14 and 18. We'll start with 1 and 14, and we'll start with the 1 and 18. Then we'll have 2 and 9, 3 and 6. Luckily, since these are both pluses here, we're pretty sure we're going to be working with just positive numbers here. All right, so let's work with that 1 and 14, 1 and 14. All right, now this is all the factors of the 1 and 18, but not all the factors of the 14. So going back over here, I have 2 and 7. And again, I would list the 1 and 18, the 2 and the 9, the 3 and the 6, 2, 7, 2, 7. Then I believe that is all except for maybe possibly some order changes if I did 7 and 2 versus that. But these are the only factors of 14 are the 1 and 14 and the 2 and the 7. All right, so now looking at these, the outer here would give me 18. The inner is going to give me 14. 18 and 14 would add together to give me a 32, not a 33. So that doesn't work. 1 times 9 is 9. 2 times 14 is 28. Add those together, you get a 37. No good. 1 times 6 is 6. 3 times 14 is 52. Definitely no good. All right, go on to these. 2 times 18 is 36. Plus 7 is definitely going to be more than 33. 2 times 9 is 18. 2 times 7 is 14. 18 and 14 add together give you a 32. 2 times 6 is 12. 7 times 3 is 21. We have a winner. 12 and 21 do indeed add up to give me 33. So we're going to work with 2x plus 3 and 7x plus 6. And when you do the first, 2x times 7x gives you 14x squared. Outer gives you 12x. Inner gives you 21x, which we already calculated would add up to give me the 33x. And the last, 3 times 6 gives me the 18. Now, in this particular case, even though it took us a while to get to that last answer there, we probably could have skipped the 1 and 14 stuff. Because chances are 14 times any of those factors is going to make it too large. So we could have skipped right to these factors. One of those ways of skipping through all the work here is look for the ones that are going to actually give you numbers close. Now, if you were to try and do the AC method with this is one where the AC method would be kind of messy here. Because you would have x squared plus 33x, and then you'd have to do 14 times 18. 8 times 4 is 32, 8, 11. You get a 0 here, you're going to get 14. So you would get 252. So I'd be looking for the factors of 252 that add to give you 33. Not so easy. So sometimes that AC method just is not going to pay off. You have to start listing the factors of 252, which would be 1 and 252, which definitely wouldn't work. Then you have 2 and 1, 26. 3 goes into 25. 8 times 1 left over, so it's 84. And you have to keep going like that until you find all the different factors of 252. 4 goes into 25 6 times with 1 left over, which would be 63. So 4 goes in 63 times. 5 doesn't go in. 6 goes into 25 4 times with 1 left over, so 42. As I start getting closer, I can see 6 and 42 are getting closer to possibly working out that way. 7 goes into 25. You just keep going. 7 goes into 25 3 times with 1 left over, so this would be 36 times 7 would be giving you 252. 8 goes in 30. No, it doesn't, does it? 8 goes into 25 3 times with 1 left over. No, 8 does not go in evenly. 9 goes into 25 twice with 7 left over. 9 goes in 27 times, I believe. Or is it 26? 18, 7 leftovers, it'll be 28. It'll be 28 times. Add those together, you're definitely not getting 33. 10 is not going to work. 11 goes into 25 two times with 3 left with 3 left over. Does not go to 32. So 11 doesn't. 12 goes in. 12 does go in. It goes in 21 times. There we go. We finally figured out 12 and 21 are going to add together to give me the thing that. So notice, not always going to work as well as the other method, but sometimes it would help. All right. Okay, that's the end of this video. Hopefully it's been helpful. Hopefully you learned a bit about the AC method versus the normal textbook method of listing all the factors. Either way will work as long as you follow the rules within them. If you have any questions, please don't be afraid to ask them in class, or you can post a comment here. Thank you for watching, and if you would like to subscribe, please do so.